As we're talking about the average rate of change, it's important to touch base on the difference quotient. What is the difference quotient? It can be defined as the average rate of change of function f with respect to x. This can be called a difference quotient. What is the equation of difference quotient? It's exactly as the average rate of change, but instead of having x1 and x2, we're having f of x plus h minus f of x over h, which can be imagined as the horizontal difference of the x values. As we mentioned before, h should not equal 0, so that will not have an undefined value. So the difference quotient is equal to the slope of the secant line, which is the straight line we draw between the 2 points on the graph that we have of that specific function. So the difference quotient equal the slope of the secant line from the point of x and f of x over here to the point of x plus h and f of x plus h. So imagine instead of having x1, y1 and x2, y2, we used to have the rate of change y2 minus y1 over x2 minus x1. Now we're having different points. We have x and f of x and x plus h and f of x plus h. If you do exactly that for y2 minus y1 over x2 minus x1, you will get f of x plus h minus f of x over h. So here we are having x1, we are having here x2, we are having here y1 and y2. Just different representation of the rate of change that can have its own specific applications and simplification for some special cases solutions for the average rate of change. Example, if you have f of x equal x squared, find the difference quotient when x equal 5 and h equal 3. That's easy. We have this equation in mind, f of x plus h minus f of x over h. We have h as 3, we have x as 5, so f of 5 plus 3 minus f of 5, that's what we have here, over h, which is 3. That will give you f of 8 minus f of 5 over 3. Now, f of 8 can be plugged into this equation. 8 squared is 64. F of 5 can be plugged in here. F of 5 equal f squared, which is 25. So we can change those f of 8 and f of f into their resulted values. 64 minus 25 over 3 give you 13. So it is important to remind you that the difference quotient equal 13, same what we mentioned in the average rate of change. That represents the slope of the line from the point 5 and 25 to 8 and 46. Why we see that? 5 is x, 25 in this case is the f of 5, and we have 8 as of x2, and f of 8 is 64 as of y2. Or let's say the other branch of the example, which is b, x equal 5 and h equal 0.1. Plug in the numbers for x of having 5, h 0.1, x of 5, h of 0.1. You get f of f 0.1 minus f of 5. So f of 5.1 minus f of 5 over the h, which is 0.1. f of 5 into x squared, you get back 26.01 minus 25 over 0.1. That gives you 10.1. Branch C of the solution, x equal 5, h equal 0.01. Same thing, you plug in the x and the h wherever you see it. And when you have f of a certain number, you plug it back into the main equation that represents the f of x. And you get back the final value of 10.01. So that's mainly a fast overview over the difference quotient in case we need it as we move forward.